Here we have a problem on derivative. There is a function given over here that is y equals to logarithm of 1 positive x square to the base x square per power, and we have to find dy over dx. That is, we have to find the derivative of this function with respect to x. Actually, the given function is a logarithmic function because it contains logarithm on the right side. So whenever I want to find derivative of a function which contains logarithm, it has to be a natural logarithm so that I can find its derivative easily. Okay, let's consider the derivative of a simple natural logarithm function, that is ln x. So here, whenever I write the spelling ln for a logarithm, it will be understood as natural logarithm and its base is e, and we don't have to mention the base e for this one. Okay, I want to find derivative of this ln x. What is it? So first I have to write 1 in numerator, and in denominator, whatever argument I have for this natural logarithm, it has to be written in denominator. So this is the derivative of natural logarithm of x. So when I have a natural logarithm in a function, I can find its derivative easily. So my first work in this function is I have to convert this logarithm to natural logarithm before finding derivative, so that I can find the derivative easily. Okay, how can we change the given logarithm? Actually, the given logarithm is having the base x cubed. So how can I change this given logarithm to natural logarithm with base e? So first let me write the given function as it is. That is log of 1 positive x square to the base x to the third power. Okay, to change this logarithm to natural logarithm, what I need to do is I have to write the natural logarithm. This is ln in a fraction in numerator and denominator. So for the natural logarithm in numerator, I have to write this 1 positive x square as the argument. So then I get natural logarithm of 1 positive x square. And for the natural logarithm in denominator over here, this x cube has to be written as argument. So this is how we have to change a logarithm to natural logarithm. So now what I need to do is, and also if it is possible, I can use the properties of logarithm before finding derivative. So here I can use the properties of a logarithm. This is a power rule of logarithm. So whenever the argument of a logarithm is exponential, the exponent over here can be moved in front of the logarithm. So let's do that. So that I'm getting ln of 1 positive x square over, when I move this exponent 3 in front of the logarithm, then it will become 3 times ln x. Okay, so 3 is a constant, and so since it's a constant multiplied by the complete denominator ln x, it can be, this constant can be written separately from the function. Then I'm getting y equals to 1/3 times ln of 1 positive x square over ln x. Okay, so now it's a constant and it's a variable because this part contains the variable x. So whenever a constant is multiplied by the variable, and when I find derivative of such a function, I have to keep the constant as it is and find the derivative of the variable alone. Okay, so here, and also when I consider the variable part, I have variable in both numerator and denominator. So when I have variable, when I find derivative, if I have variable in both numerator and denominator, I have to use a quotient rule. What is a quotient rule? Okay, let me write it over here. So let's consider the division of two variables u and v, and if I want to find derivative of this one, so what I need to do is first I have to take the square for the denominator, that is v square. The same denominator should be taken over here, and find the derivative of the numerator, then it will become u prime. Then I have to take negative sign. Now I have to keep the numerator u as it is and find the derivative of the denominator v, then it will become v prime. So this is quotient rule. So the same quotient rule we have to apply in our problem to get the derivative of the function over here. Okay, first let's find the derivative of this y with respect to x. What do I get? I get dy over dx. Okay, to get the derivative, okay, and also it's a constant multiplied, and we have to keep the constant as it is. Now let's find the derivative of the variable part. So here I have to use quotient rule because it contains variable in both numerator and denominator. So first I have to take v square, that is the denominator has to be square. Then I'm getting ln x the whole square. The same denominator should be taken in numerator, ln x. And I have to find the derivative of the numerator, which is ln of 1 positive x square prime negative. Now I have to keep the numerator ln of 1 positive x square as it is. Get the derivative of the denominator, that is ln x prime. Okay, so then the next step, dy over dx equals to 1/3 times ln x times, when I find the derivative of this ln of 1 positive x square, so first I have to get the derivative of this natural logarithm. For that I have to write 1 in numerator, and whatever argument I have over here, it should be written in denominator. Further, I have to do derivative for this argument by chain rule. So when I do derivative for this argument by chain rule, the derivative of this 1 becomes 0, and the derivative of this x square becomes 2x. So times 2x negative ln of 1 positive x square. When I find the derivative of this natural logarithm of x with respect to x, it will just become 1 over x. And in denominator, we have to write ln x whole square as it is. Okay, so in the next step, dy over dx equals to 1/3 times, okay, so we can multiply this ln x times 1 times 2x, then I'm getting 2x times ln x over 1 positive x square negative. When I multiply this stuff by 1, I'm getting ln of 1 positive x square over x, and this complete stuff has to be divided by ln x the whole square. Okay, let me erase the stuff over here and continue the process. Okay, we got the derivative. So what we need to do is we have to do the simplification process. Here we have subtraction of two fractions. So here and also the fractions that do not have the same denominator, and also the denominator contains a variable. Okay, so how do we have to simplify the stuff over here in numerator? I have to do cross multiplication. That is, cross multiplication means I have to multiply this numerator by this denominator and this numerator by this denominator, and at last I have to multiply the two denominators. Okay, let me do it. So first let me multiply this 2x times ln x by this denominator. Then I'm getting, 1 second, let me write dy over dx on the left side, and 1/3 times, okay, now when I multiply this 2 times x times ln x by x, I'm getting 2 times x square times ln x negative. When I multiply this numerator by 1 positive x square, I'm getting 1 positive x square times ln for 1 positive x square. Now I have to multiply both the denominators, 1 positive x square and x. I'm getting x times 1 positive x square. The complete stuff has to be divided by ln x the whole square. Okay, here in numerator we have a fraction. In denominator also, if I have a fraction, I can easily simplify. So I assume this ln x whole square as a fraction by taking denominator 1. Okay, then I'm getting dy over dx equals to 1/3 times. Now I'm going to write this stuff as it is. It is 2 times x square times ln x negative 1 positive x square times ln of 1 positive x square over x times 1 positive x square times. So now I change this division over here as multiplication. Then what should I do with this fraction? I have to take reciprocal. Then I'm getting 1 over ln x the whole square. Okay, so then dy over dx equals to, so we can multiply the numerator 1 and this numerator 1. Then I'm getting 2 times x square times ln x negative 1 positive x square times ln of 1 positive x square over, when I multiply the denominators, so there are 3 denominators, 3x times 1 positive x square and ln x whole square. When I multiply all the 3 denominators, I have to write them together. So 3 times x times 1 positive x square times ln x the whole square. Okay, now I got the derivative of the given function. So this is the derivative of the given function with respect to x.